Okay, so we spent the past kind of couple of days making a connection between using the models like the counters and like the number line to come up with a rule for what happens when you add positive and negative numbers. The nice thing about the rule is that it works for any kind of positive or negative that you're adding. And so that includes really big numbers or little numbers or fractions or decimals. Now, realistically, we're going to start by doing this and asking a bunch of questions along the way. You're not going to do that forever. Hopefully, if we ask them enough, they're going to stick in your head so that no matter where you go or where you end up in math, you're going to keep asking yourself these same questions whenever you have positive and negative numbers that you're trying to add. So, the first thing you're going to ask yourself whenever you see two numbers that are being added that have positives or negatives in them is the question, are the signs the same? And I'm actually going to zoom in here so you can see a little better. Are the signs the same? And so there's two possible answers you could give to that. Yes or no. Okay. So if you'd say yes, that would mean that both numbers are negative or both numbers are positive. If you say no, that would mean that both numbers, or one is positive, one is negative. So if I kind of go add that in there for myself, I'll make this just a little bigger here. I could say yes, and then that would either be positive, positive, or negative, negative. Okay, and so no, we can go ahead and drag this, make it a little bigger too, would be something like if you had a positive and a negative, or a negative and a positive. So going back to if I say yes, the signs are saying yes, so we have positive, positive, negative, negative. Well, with that one, remember we just made all the chips. There was nothing to cross off. And so because of that, we just had a certain number of chips or counters to count up. And so because of that, really what we're doing is adding the digits. Ooh. And so then the answer is going to have the same sign. Meaning that if they were both positive numbers, it would be positive. If they were both negative numbers, it would be negative. Because when we built those with the chips, right, you only had used yellow or you only used red. So that's how your answer ends up that way. Versus with the no, when you have one who's positive, one who's negative. Well, with those, if you thought about what happened with the counters, we had to cross off some of them because we had some zeros that we could take away. Or if you think about the number line, you kind of went in one direction from zero and then had to go backwards the other way. And so because of that kind of doubling back or the zero pair crossing off, what we're really doing with these numbers is subtracting the digits. And so what we would say about the answer then was that it was whichever one had more chips that would be left over, or more counters kind of left over, or kind of which one took us farther past zero if you're looking on the number line. So because of that, we could say the answer has the sign of the bigger digit. So I'm not going to say the bigger number because obviously positive numbers are always bigger than negative numbers. So that would mean every answer is positive, and that's not true. I'm saying if we look at the digit, like the 1 or the 4 or whatever you got, which one of those digits is bigger? There's a fancy math word for doing that. It's called finding the absolute value. Okay. So let's try to use this rule down here. First problem we got, negative 40 plus 10. So first question I would ask, are the signs the same? So being the same would mean they're both positive or both negative. And my answer here, there's a negative and a positive, so it would be no. Then my next question is, what are we going to do with the digits? So if we look there, my answer was no, right? So we're going to subtract. Oops. And then is my answer going to be positive or negative? So on the no side, it says the answer has the sign of the bigger digit. So here we have, if I ignore the negative, we have a 40 versus a 10. 40 is a bigger digit than 10 is. So therefore 40 is negative, so my answer is going to be negative. So then I'm actually going to do it. So 40 minus 10, because it said subtract, right, is 30. And it was supposed to be negative, so I'm going to type negative 30 for my answer. Okay, let's try another one. So over here, we had negative 50 plus negative 60. So again, I'm asking, are the signs the same? Yes, because they're both negative. So then I need to add the digits. My answer has the same sign. So signs were the same. Yes. What are we going to do with the digits? It said to add them. And will my answer be positive or negative? So the answer is going to have the same sign. So since both of these are negative, my answer is going to be negative. So then I'm actually going to do it. So 50 plus 60, I could really know that 5 plus 6 is 11 and add a 0. So that would be 110. And then it said negative, so I'm doing negative 110. And that's the idea of using the flowchart.